increasing in volume. This rise and expansion of magma occurs abruptly, so the movement of hot magma occurs at high speeds. When the hot magma ascends higher, it meets a stream of colder magma, because the closer to the crust, the colder it becomes. The temperature difference between them can be just a few degrees, but it is enough to form magma flows of different temperatures heading towards each other. Some new magmatic rivers approach directly under the very plate. This is what we observe in Siberia. After magmatic rivers transfer their heat to the plates, they cool down and descend. And when the descending river of magma meets the ascending red-hot river coming from the core, their collision leads to what we call cavitation explosions. These powerful cavitation explosions release gases. The cause of the explosion is actual nuclear reactions that release enormous amounts of energy. It would be more accurate to call it an intramantle nuclear explosion. However, we call these explosions in the mantle cavitation explosions only because of the associative similarity. It is these explosions that are being registered as deep focus earthquakes. The greater the contrast in temperature, velocity, and pressure between the colliding magma rivers, the greater the explosion. In terms of power, these explosions are equal to millions and billions of nuclear bombs, and they have never occurred in the mantle in such quantities before. Take a look at the map showing the frequency and number of deep focus earthquakes in recent decades. Currently, deep focus earthquakes are also being detected outside the plate's boundaries, and scientists have no idea how to explain this. Look at the map with the examples of the earthquakes outside the plate's boundary zone. However, they also occur in other parts of the mantle. It's just that the shock wave is not always detected and correctly identified by the